we're going to dig into generics. So let me make sure that this is projecting all right. Okay, seems to be working. All right, I think we're good to go. So this chapter here, this module is going to be dedicated to Java generics, to generic programming, more generally speaking. This is going to be probably the hardest module in the course. Okay, so pay attention, be careful, make sure that you remember everything that we covered about polymorphism inheritance. Okay, because we are going to try to go beyond this. So here's the roadmap for this module. We are going to start, like usual, easy stuff. What are generics? What are generic types? So it's really focused on Java, but there are other languages, obviously, that offer those kind of features. Okay, so you are going to be able to apply that to other languages. We are going to make the distinction between generic types, class, enums, interfaces, okay, and then generic methods. So we are going to introduce the concept of generics in two different constructs in the Java language. After that, we're going to start talking about things that do not work so well. For example, generics and inheritance. So there are some assumptions that you might have, and you would be right actually to have those assumptions based on what you learn about polymorphism. When we start working with generics, you are going to see that some of those assumptions about how we can do things with polymorphism do not exactly match the way things are done in the Java language, at least, with generics. So we are going to talk after that about bounded type parameters. So this is where it's going to become more interesting, but a little bit more challenging. So bounded type parameter is still okay. It's a nice feature, actually, as a Java language. It has some interesting restrictions. So we're going to make sure that we spend time discussing the potential for mischief of all those constructs. Okay. And then we are going to finish with type inference, type erasure. Two very important concepts. Actually, we are going to refer to those concepts all along, okay? But I'm going to delay towards the second half of the module to actually define them formally and look at them a little bit more in depth. And then we are going to talk about wildcards. And wildcards are generic plus, in a manner of speaking. And they are going to allow us actually to address some of the problems that we discussed when we covered generics and inheritance. Okay, so generics and inheritance do not quite fit well together, but once you introduce wildcards, yes, you have the full, the full toolkit of generics, and now you can do things that are interesting, including with inheritance and polymorphism. Okay, so you can mix up together everything at this point. And then we'll conclude. I'm still reworking a little bit that section because I'm not completely satisfied with it, but we'll conclude with some restriction on generics. Okay, and I'll try to add there like a little bit of review survey of all the problems that we discussed in the lecture, because there are a ton of them. Okay, that's what makes this module actually complicated. It's not so much a concept. The concepts are kind of intuitive. Okay, so it's not too bad, but it's just that once you have like two concepts related to generic, you try to put them together. There are so many possible variations. There are so many possible things you can do with generic. So you are going to see that even though the lecture is kind of dense on this topic, by the time we are done with this lecture and you start to apply it, you should have plenty of what if, case that pop into your mind. Because we do not even apply generics to all the possible structure in Java where we could apply them in this lecture. Okay? And it's already a kind of long and dense lecture. So mandatory reading, as usual, the textbook. We have it, let's use it, okay, and actually it does a good job. Both the textbook and those slides are based on the Java tutorial trail from Oracle, okay. Actually, Kai Horstman had a hand into that Java tutorial trail, so that's why you're going to recognize the structure in his books. But the textbooks goes a little farther than the tutorial trail, so it has some good explanation that should nicely supplement both the lecture and the tutorial trail. Okay, so don't consider that optional reading. Obviously, I recommend that you read it after the lecture, so you have already, kind of an introduction to the concept. Skip the section 6.7. we're not going to cover that. We're not going to mix both generic and metaprogramming together, even though this is feasible. Just as a heads up, there are limitations there. There are limitations to what you can retrieve at runtime when you try to do reflection about generic type, simply because, as we are going to study in this module, Java has a really, really interesting way of doing generics. It takes generics from your code, and then it removes them when it generates the bytecode. So that's called type erasure. Okay, so the name kind of like imply that something is going to get the chop. Well, yeah, that's the kind of information that gets the chop actually in Java. So you can intuitively, feel that if it's not there at runtime, well, I'm not going to be able to do much introspection, right? So there are still things that we can do introspection with, but we're not going to go that deep into the overlap between generics and metaprogramming. But if you're curious, this is an interesting topic. Another mandatory reading, but okay, this one is a little bit redundant with the previous one. So I guess I should have made it as a supplemental reading. This is what the slides are based on, but like I said already, it overlaps, with the textbook. So priority is the textbook. Okay, this is where the best explanations are. But if you look at a slide and you're not sure exactly, what I said back then, or the slide does not make sense anymore, well, then you can find back, some support in the tutorial trail. Last one, recommended reading. So this goes way beyond the scope of this course, okay? But when you have a question about generics, there is a very high probability that you're going to find that same question in that FAQ, and that you're going to find a very detailed response, okay? This is an exemplar work in terms of frequently asked question. When you think about frequently asked question, you think about very silly question, a handful of them, like you will find in the syllabus, etc. No, this is thorough. This is a thorough treatment of generics, including, the concept, from anything from the concept to the usage to actually what happens under the hood, okay? So I really recommend that you bookmark this resource, download the PDF from it, keep it handy, okay? Most of the questions that you're going to have are answered in that FAQ, all right? Even questions that you never thought you would wonder about. This is really, really thorough. That's my point. All right, let's get started. So we start with defining actually what we're going to talk about. So what are generics? The idea behind generics is really simple, okay? It's again a sort of, it's not really metaprogramming, right? But the idea is we are going to actually use data types as data. So when you say, I want an integer, well, right now, the only place where you can use an integer is when you define a parameter, a formal parameter, when you define an attribute, a field, a variable, okay, a return value. So you cannot do much, but what we want to do here is we want to tell a method, here's another parameter, and that parameter is integer. It's not a variable of type integer. It's not a reference to an integer object. No, it's actually, I give you a value, and that value is a data type. The same way that we passed around, class objects in metaprogramming that represented information about given class. Well, here, I want to tell a method, hey, I want you to work on integers. So the way I do it, I pass the keyword integer as one of the parameters. So we have type parameters now in methods. But we are not yet talking about methods, so methods are not the only place where we can have type parameter. We can have type parameters for entire classes, okay? So you've all used array list, okay? Array list of something. That's how you read it. Array list, chevron, and in between the chevron you have this name of integer, for example, a data type. Well, that is an example of a type parameterized class. Okay, list of integer is an interface parameterized. Okay, all right. So the generic ID is, no pun intended, but the generic ID is actually simple. Now we are going to distinguish between two categories of construct in the Java language, where we may introduce this concept of generic programming. Okay. Like I already mentioned, we can do generic types. So generic types is when you write a class an interface, an enum, an abstract class, of course, it's a class, that accepts one or more data types as parameter. So we have a way now to put parameters in classes. Those parameters are the names of data types. As soon as you have a class that accepts one or more parameter, that's it. It's a generic class. It's a generic data type. The second entry point for generics in the Java language, methods. So the same way that you can parameterize a class, enum, interface with a data type, you can tell a method to accept a data type as extra parameter. And when I keep using the word parameter, keep in mind that we are going to have a special syntax, okay? It's not just adding one parameter to the list of parameters of a method. You all understand that we need a special syntax for class because class never had parameters before. There's no such thing. So we need a special syntax. Well, the same special syntax will be used when we deal with method. So it's not just like a regular parameter. So if you want to look up a little bit more information about this, check up, well, it's kind of hidden here at the bottom, but there are 2 links directly to the Angelica Langer FAQ. You are going to get a ton more details there. So feel free to have a read. Now we're going to look at 3 different reasons. I think there are 3 of them, why we need to bother, well, why we should bother, learning generics and using generics. So the first reason is actually very, very interesting, very funny, but then again, I have a weird sense of humor. Everybody says that generics allow us to simplify notations. And you'll notice the question mark here in red, because by the time we are done with this lecture, I doubt that many of you are going to put the word simplify and generics in the same sentence, okay? Except if your sentence is, wow, I really need to simplify generics, when I grow up, because the notation can be a little, can really put you off a bit, okay? But then again, that's Java, so the notations are generally a little heavy. Here's an example of code without generics. So that should not be a problem for anyone, okay? We have a list, so uppercase L for the class name. The name of the reference variable is list with a lowercase l, and we create a new array list. So list is an interface. Array list is actually one of the class that implements that interface. Everything so far, so good. And then we call on that list add hello. So we are adding a string to that list. So that kind of tells us that was meant to be a list of strings, but we never said anything like that until now. And then we get out of the list at index 0, the first element, pretty much. We pop the first element, and we convert the return value, which is a reference, to a reference on an object of class string, and assign this to S. Okay? Nothing really fancy there. So the idea of generics is that we are going to somehow simplify this. So here's how we are going to simplify this. So it really looks similar, actually, except that instead of doing a typecasting to string, okay, in the assignment to variable S, we got rid of that typecasting. So that's good, right? That's simplified. And then we had to add a little bit of weird syntax here, which is a syntax to pass actually actual data type parameters, okay? So here I say that my list, now I'm being much more specific. It's a list of string. Okay, and then when I create the array list object, I specify to the array list that it has to be an array list of string. So it needs to match, okay? So whether removing 1 time string with parentheses around it and replacing it by 2 times string with chevron around it is actually a simplification, that can be open for debate, okay? But I'm just being a little bit of a insert pejorative word here, because really, if you are using that list a lot in your code, you are going to do a lot more typecasting than declaration. Okay, so yes, to be honest, even if we had to put those double chevron string notation there, lesser than, greater than, well, yeah, it would still be a simplification, I guess. And what's more, we're going to learn that we don't have to repeat the string, during the declaration of list and during the creation of the object. So yeah, on this example, we might have actually some degree of simplification, but that's not really the most important thing. That's not really the main advantage, and nobody would put up with generics if it was just to gain that again. The main advantage is that now we are being a lot more accurate, okay? We are saying that our list is a list of something, and when we assign to it, then it goes by itself that we are going to assign, for example, in this case, strings, okay? References to string. So that's really what we are going to exploit, and that's the reason to use generic. Well, that kind of makes leeway into the second reason for which we should bother, which is actually kind of what I just said. Because we are more accurate in our definition, okay, we are going to enable the Java compiler to do more of what it's already good at doing, type checking. Okay, if you don't like type checking, that's fine. There are plenty of languages that are going to allow you to use, weakly typed constructs, and that are going to allow you to do things like duck typing, okay? And but that's fine. But here we're talking about a language that is compiled and does an extensive series of type checks, on your code to prevent errors at compilation time. So in this context, well, we just extended the capability of the compiler. So let's take a quick example here. Again, this is our array list. We're going to use a lot of those array lists in this module. We add the string hello, and then we try to add an integer reference. Well, nothing in this version of the code, nothing really tells you that you could not have heterogeneous list, okay? You could have an heterogeneous collection, a collection that contains various data types, okay? So that's what I'm doing. Why not? And then when I want to extract elements, I'm going to do, okay, I extract the first element, and I know it's a string, so I'm converting to string. Because otherwise I would have a problem. We're going to get more into that. And then my second element, which was an integer, index 1, well, yes, I get it from the list, and I know that I need to convert it to an integer. So that's two sentences where I said, I know as a programmer, right? Okay, so that means that these are sources of bugs. If I forget my first element is a string, my second element is an integer, then I'm going to start making mistakes, okay? That's actually the weakness of not using generics, actually. Plus there's silly situation. Well, that would be one of the mistakes we could do. Like, this is an example of silly situation. I forgot that I had anything but string, in my list. So when I fetch element index 1, I just assume, hey, it's going to be a string too. So that's not going to work very well. What's going to happen in this case? Yep. Runtime exception. So why is it bad? Well, it's bad because, and we go back to that dilemma between strongly typed language and weakly typed language. And I'm not advocating that, only strongly typed language should be used or only weakly typed language should be used. I just want you to understand the difference so that then you can learn to use the right tool for the right task, okay? The main issue here is that we are making a trade-off. When we are doing this type of programming, and some language, just work with that. There's no generics. There's no way for the compiler to detect problems. So when you are in that situation, you can write code very fast. You don't have to fight with your compiler to get things to compile. But then you have to check for problems at runtime. So the argument that goes around is, well, everybody has to write unit tests anyway. So if you are going to write unit tests anyway, yes, the compiler could find some trivial errors for you, but you can write unit tests that are going to look for those kind of errors. So you can try, to do this kind of stuff and then trigger errors, and then you're going to fix your code. Yes and no. My personal opinion on that is that, yes, you can catch everything at runtime if you want, and you can use unit tests to catch that. But the amount of unit tests you have to write is dependent on how much a compiler can do automatically for you. So it's really a trade-off. You trade spending more time writing unit tests, to catch errors at runtime, with spending more time struggling with the compiler because your compiler is really hard on you and doesn't let you compile, what you want to do and gets in your way. But finally, when you get it to compile with the compiler, there is a whole slate of possible mistakes that have been prevented. So it's up to you. You prefer to fight with your compiler and get it, to work until it compiles and everything is shiny, or you prefer to fight at runtime with your unit tests and make sure that you have all possible unit tests that could trigger a problem. Again, I think it's mostly a personal preference. I would just be concerned that if I was writing the unit test, I would probably get bored writing very basic unit tests like this, and I would end up like missing things. So everything I can automate, I tend to like automating it. But then again, it's a matter of programming style, so there's no right and wrong there. Third reason, it's kind of a tautological reason. Why do we bother learning generics? Well, so that we can use generic programming. That's a great reason, right? So it's almost a political statement. So behind this tautological aspect, there is actually some truth. The truth behind it is that one of the main motivation for the development, for the advent of generics in programming is availability of collections, I would say. Collections are probably the primary client for generic programming. You might not use generic programming in your project, you might not write generic class or generic method, but you will use generic programming just because of the collection of your favorite language, okay? So the idea of the collection is that you don't want to write the code for a list. I mean, you don't want to write an interface for a list and then write a class that is a string list that implement this interface. And then write again a class that is an integer list that implement this interface. And then write again, you got the picture, okay? Why? Because all of those classes, the logic is 90% similar. There are very few things that are going to change between the code for actually an integer list and the code for a string list. You manipulate different data type. So this is where generics really shine, okay? When you are in a situation like this, generics allow you to factor your code one more level, to avoid to repeat yourself again, okay? Same thing we said with metaprogramming, okay? I told you one of the examples we use in metaprogramming, I said most programmers would be happy with that, but then the programmers that know metaprogramming techniques, they look at this code, they say, you repeat yourself. Let me factor this out. Okay, same thing here. If you don't know about generics, yeah, you're going to write different class that pretty much do 90% of the same work. If you know how to write them in a generic manner, your code is going to be much more flexible. So that's the second item bullet. I already pretty much covered it, so I'm going to jump to the next step. The next step is going to be starting with one of the two ways to introduce generics in Java. Okay, so generic type, generic method. We start with generic type. So classes, interfaces, abstract classes, enum, all that stuff. So the first question we're going to address, it's always a good sanity check, kinda. Okay, every time you learn a new technique, I already told you, make sure that you see why it's necessary. So we are going to talk about whether we can do generic programming without generics. And surprisingly, the answer is yes. You can do generic programming in Java. As a matter of fact, it was done before generics were added to the language. It was done in other languages before those languages add generics as well. The main issue here is that you don't have type safety when you do so. So it's very important, okay? Most of you are going to, at some point, I would say a majority of you at some point are going to struggle and wonder, why do I need this? As I'm spending like 10 minutes on one feature of generics. The answer is probably you don't need it. You can do it differently in Java without using generics. So the real question you have to answer is, what is the benefit of me using generics instead of trying to rig something to do the same job without using them? Okay? Because most of the time you have that option. So the answer is going to be always going back to type safety. If you use generics, the compiler understands what you're trying to do better. Not always, but much better. If the compiler understands what you are trying to do in your code, then the compiler can apply a series of automated checks to make sure that you are using those classes that are generic classes really the way you intended to use them. That's very important, okay? It's very simple to understand, but that remark is going to completely change the way that you look at a lecture on generics or a textbook on generics or a tutorial on generics, okay? Because you're going to stop having this nagging feeling of, well, I don't see why I have to use that. I could do it differently. Yes, you could, but then think about this alternative method that you have in mind. This one is probably not type safe. All right? So keep that in mind. We're going to come back to it. So, as promised, here's the first part of the lecture on generics, where we are trying very hard not to use generics. That makes perfectly sense. So here's the box. That's by the way, the hello world of generics tutorial and textbook and lecture. Everybody uses a class box. So I wanted to be original. I used it too. Public class box. The only purpose of the class box is to contain something, and that's where the genericity comes into play. Okay, we have a private object field, and the data type of that field is object. So technically, an instance of the class box can hold a reference to any object that is created in your JVM. Everything inherits from object, right? So we are using polymorphism here. So we have a setter, we have a getter. This setter allows us to pass a reference to an object, for example, an employee, and we store that in our field object. And then we call later get me the data out of my box, and of course we return the reference that we stored. That's generic programming. A box can hold any type of object. Definition of generic programming itself. How do we use it? Well, here's the main method that's going to use our class box. Okay, so box B equal new box. Nothing fancy there. Then I create an integer. So watch out. My box right now can hold any instance of a class. Cannot hold primitive data types. Okay, primitive data types do not inherit from object. There are special cases in the Java world. So instead of the primitive data type int, I use the class integer. So create an object of class integer, holds the value 42, so it's just an object wrapper around an int value, and then I put the reference in a variable n1, defined as a variable meant to hold a reference to an object of class integer. Everything is working, everything is shiny. And then b.set n1, I pass my reference of my newly created integer object to my box instance. And I say, okay, remember that reference. No problem there. And then I want to get out that reference. And this is where the problem starts. I say I have a double n2. So n2 is a variable meant to hold a reference to an object of class double. And I say, get me the reference that you have in the box, which is a reference on an object of class integer. All right. So I try to run this. It's not going to even compile. So this is what it's going to tell me. Incompatible types. Object cannot be converted to double. It doesn't tell me integer cannot be converted to double. Why? Yeah, go ahead.
Specify anything in the class.
Well, we didn't specify integer in the class. Yeah, that's correct. So what did we specify in the class? Object, yeah. You had a
reference of integer stored in an object of class object.
So
it's saying incompatible types object, because it stores the object which we return is nothing but an object of class object, but stores the reference of integer.
okay, yes and no. You're like 90% right. There's just one thing I want to correct, okay? So we did store actually inside the instance of our class box an integer object. That's the part I want to correct, okay? We do have an integer object. So we have a reference to an integer, okay, inside of our class box. But it's assigned to an attribute of data type object. And what's more, our get method is defined as returning an object. That's really the crux of it, okay? You have to most of the time the computer doesn't make mistakes. We make mistakes, programmers, okay? So most of the time, you told the Java compiler that you wanted an object reference out of calling get. You did that. And now the Java compiler is playing the role of karma, is serving you back what you gave it. That's it. So it's not abnormal. It's not an error here. It's not a flow of Java or anything. Java is just following our orders blindly. Okay? So we said, give me back an object reference, and now we want to assign it without any typecasting to a double variable. That's not going to fly. So how do we fix this? Easy. So the only difference here between the previous slide is what's in red here on the last line. I put an integer inside, but now I want to extract a double, so I just have to do typecasting, and the compiler is really happy with this. So we solved our problem, right? It's a trap. No, say no. We didn't solve our problem yet, okay? The thing that is not quite working here is that we got Java to agree with us. So you did a great job. You fast-talked the Java compiler. You convinced Java that you knew what you were doing and that it had to overlook this little detail about, yes, I put an integer, now I'm getting an object, but really I want to look at it as a double. Okay, you made the compiler shut up. Congratulations. However, reality still is there and comes back to kick you around, because the reality is that once you do this, you are going to try to convert into a reference to double, a reference that is a reference to integer. That's a problem. Okay? At the very least, it's a problem in the sense that it sounds like you don't know exactly what you stored in the box. It sounds like you forgot about it. You put an integer, now you tell me you want a double. This is not a magical double factory. Okay? So that's the idea here. It's like you are inconsistent in your usage of that generic box, that generic container. Yeah?
Yeah, I have a question. So, if, for example, we have like code double n2 equals new integer 42, it will not compile, yes? Like if I have just like declaration double n2 equals new integer 42. So Java will not convert integer class to double automatically.
Even if it does, even if it was converting automatically your integer object, by taking actually the value that is being wrapped, converting it to the primary data type, primitive data type, from int to double, and then putting a new wrapper around it, which is very feasible. You can automate that. You can do that kind of typecasting automatically. But even so, you have no idea that you are losing, precision. You see what I'm saying? You're like putting an object that is, for example, well, in this case, we're putting an integer, we're getting a double, so we don't lose precision.
No, I mean, for wrappers, it's not automatically performance, this conversion. For primitive types, I can assign to double, but for wrappers, I cannot do it in Java, yes?
I don't know if you can in the latest version of Java, because like I said, it's something that can be automated, actually. There's no theoretical limit that say, no, you cannot automatically generate the conversion between wrapper. So whether they already implemented it or not, I don't know. Have to track the change log, and see when it's going to pop up, pretty much.
And for me, it seems that it will be like runtime error, yes, runtime exception, but for me, it means that if it even performs this conversion from double wrapper, from integer wrapper to double wrapper, it seems that it performs it in compile time, not in the runtime. So it's like it cannot do this conversion in runtime. Yes?
No, you can do that conversion at compilation time. Yeah, you can, because you have all the information there to allow you to decide. There is a problem. That explicit conversion here, that explicit typecasting into double, well, that can be handled at compilation time. That's why this version fixes some of the problem of the previous version. Okay, in the previous version, the only difference, like I said, is what is in red. So in the previous version, we were just saying, okay, I just want to assign, what I get to my double n2, and the compiler said, well, I cannot transform an object into into whatever you have for n2, which is a double.
Oh yeah, but it's typecasting. Yes, it works on compile time. I mean, like code that will recreate wrapper. It's like it will not be generated by compiler here.
That's the principle of autoboxing, yeah. Like everything that has to do with wrapper class, as far as autoboxing goes, is generated by the compiler, automatically at compilation time, pretty much. Did that address your question? Okay. So we have something that's a little bit better here. We're not out of the woods yet. Okay. What we really need here, and that's again the definition of generics. What we really need here is a way to enable Java to check our code for such inconsistency. And a theme that is going to keep coming back and over and over in this lecture is the assumption that when you have a collection, you want an homogeneous collection. Okay, when you have a container, when you have a box, when you have you want consistency. For example, if you have a list, it's a list of all strings, or a list of all integer, or a list of all double. Now, if you want, again, to kind of anticipate, things that generally raise questions and concerns when you first learn that kind of stuff, if you want to have a list that is truly generic and has maybe different data type for every single element of the list, there are ways to do that, okay? But in that case, generics are not going to help you, okay? Generics allow you to do things that are homogeneous, that are like list of integer, and then the Java compiler is capable to validate your code to make sure that every time you add an element to that list, and every time you get an element out of that list, or that container, or that box, okay, like in our previous example, that you still inject and retrieve element of the right data type. And that's really the fundamental issue with the previous example, okay? Regardless of whether it's detected at compilation time or runtime. I mean, it's better compilation time in my opinion, but leave that alone, okay? If we don't care, then independently of whether this is detected at runtime or compilation time, the real issue is there's no consistency. You put one thing in, you take another thing out. You have the first element of your list of one data type, the second element is of a different data type. That's the kind of stuff that generics allow us to fix, okay? Actually, they don't so much allow us to fix it, they allow Java to understand enough about our code to automatically detect those violations of type consistency, okay? So let's use generics, finally. After a few slides where we tried very hard to not use generics, let's use them now. So there's a Where's Waldo exercise here. On the left, you have the non-generic version of our box class. On the right, you have the generic version. And it's not too bad, okay? We talked about simplifying notation. We are not yet to the part where you guys are going to bang your head on the desk because of the notation. This is easy. This is actually clean. This is nice. So we have here extra notation. We use this uppercase T. And you are going to see that most of the time the type parameters are represented by one uppercase letter. It kind of became a convention in Java. So we say that we have a box of T, whatever data type T is supposed to represent. So that's a type parameter. And then we use that type variable here, T, wherever we can use data types in our code. So we say, okay, I want a field, a private field. Instead of calling it object, I called it T, okay? So that's another difference, but it's not significant. But most importantly, this is not a data field of type object anymore, at least until type erasure comes into play. But for now, it's a data type T. So the attribute T is of data type T, whatever a specified T was. So if I said I want a box of integer, then everywhere I use T, consider it replaced by integer. So here, same thing. My parameter is of type whatever you specified when you created an instance of that class. And my return value for the getter is of whatever type you specified when you created an instance of box. Okay, so when I create an instance of the class box is when I actually pass a type argument. I say, okay, I know that box accepts a type parameter T, so now T is going to be integer or double or employee or whatever you want, okay? That's when it's going to happen. But you write the code so that it can work with any type T. Let's go over the syntax real quick, and more than the syntax, the jargon, okay? So we are talking about generic data types. So that's going to be a class and enum abstract class interface. So in this case, it's a class. This part here, you know how when you write a method, you have, when you write the method, actually, you define the method, you have formal parameter, okay? All right, some people refer to them just as parameters. And then when you call the method, you have effective parameter, or people call them actual parameters. and some people even use a different word. They use arguments. Okay, so you are used to that difference of vocabulary, right? Same thing here. We are passing parameters that are type parameters. So this is called a formal type parameter definition. Okay, I want a parameter t for my class. All right, and then this is your formal type variable. So it's going to hold the value of the data type that you specify when you create the object, and you are going to be able to reuse it throughout the code, just like you would use a method parameter. Just keep in mind, no primitive data type. Arrays are okay, any class is okay, just no primitive data type. Generics do not work with primitive data types. And then wherever you would want, to use that type, well, you just use t as a marker, right? As a replacement for it. I told you that we had some conventions. So this is not enforced by the compiler. You could call your type parameter whatever you want, okay? But the convention is Java to help, a little bit with the notation being heavy, to help spot quickly, type parameter in the code. The convention is use one single uppercase letter, okay? So if, for example, your type parameter is supposed to represent the data type of elements in a collection, generally we label it E. If it's a key, like in a hash map, okay, we use K or V. V for value, K for key. That's the traditional hash map setting, okay? If it's a number and if it's a generic type, nothing more that you know about it, then use T. And we are going to see that we can have multiple type parameter in generic types. So if you need more, use S, U, V, whatever, okay? Whatever makes sense, or those letter S, U, V. I don't know where they come from and why they are so popular, but this is what you are going to see, at least in the Java collection code, okay? Now that we talked about how to write a generic class, let's spend a few minutes on how to instantiate a generic class. So it's easy. And we're going to see that we can even simplify. This is a notation I used in my first example. We're going to simplify this a little bit. So more jargon. And actually this line here is a little too long. The line that goes over box, integer box, should be a little shorter and cover only the part that says box of integer. So sorry about that. I'll try to fix that next time I use the slide. But this part is a parameterized type. Okay? So it's an instantiation of a generic type. And this is where the vocabulary kind of gets in the way, and not everybody agrees on that vocabulary either. Okay, so we'll try to be really careful. But the generic type is box of t. You define a type, box, and it's a generic type, and it's a box of t. That's the type parameter. So now what you do is you specify actually what is the value of the type parameter. That's the meaning of the word instantiate in this context. Has nothing to do with creating an object. Okay, we are not creating an object yet. Okay, I'm just commenting right now on the box of integer, keywords that are just on the leftmost part of the statement. So I didn't create anything, but the terminology is this is an instantiation of a generic type box of t with the actual type parameter integer. Question? Yeah.
So the constructor for a generic class, does it have to have, so for the class box in the previous, it just came from the constructor will only have box and then the brace brackets, the box parentheses and brace brackets, or
okay. So the question is about the syntax here, or of the definition of the class box?
Yeah, if I want to write a constructor for the class box,
yeah.
Will it be box parentheses and then brace brackets, or box the type and then parentheses and the brace brackets?
Okay, we're going to get back to that in a few slides. Okay, so all that question for now, but we're going to get there. The question was, how do I write a constructor? Do I have to specify if I write the constructor for the class box, the t between chevrons, between angular brackets? Depends. You don't have to specify t because it's understood that t is a parameter of the class. So when you create an instance of that class, you have to tell what the value of t is, and you do that by passing it to the constructor. But when you define the constructor, you don't have to remind it that you need t, okay? However, you could have also a constructor is a method, after all, that has its own type parameter. So you might still have to define type parameters for a constructor. So that's why I don't want to answer that, just right away. But as soon as we get into method and constructor, you are going to see the difference, okay? But right now, you see that I don't have a constructor, so I'm using my default constructor. And when I call actually the constructor on the rightmost part of the statement, new box of integer, then I specify here the type, okay, that I want to use for the class. All right? Yep, question?
The next question would be, so we've done metaprogramming, and
Yeah.
so like integer is nothing but a wrapper class. So if I want a custom class, so can I use a reflection to use by using just the class name and then use it as a type?
Okay, I'm not sure I understand 100% the question. The question is, hold on, let me try to tell you what I understand and you correct me, okay? What I understand from the question is, can we use first step, can we use custom classes? So yes, instead of integer, you could use employee, stuff like that. But then you ask whether we would have to use metaprogramming in that context. No, you don't.
My question is, can we use metaprogramming?
You can. Remember, I mentioned in the first slide that in the reading assignment that you can actually put together metaprogramming and generics. It's just that because of something called type erasure, at runtime you are going to have actually less information about your generic types. So you can still do some things, but it's not as powerful as it could be. Let me put it that way, compared to other language like C# or stuff like that. Okay. So integer on the left, I already mentioned that this is actual type argument. Integer on the right between the angular brackets is also the actual type argument. But again, and that was actually a good question, this is not a type argument for the constructor here. This is a type argument for your class. It just so happened that to create an instance of a class, you need to do what? Call the constructor. So this is the only chance you ever have to say, by the way, I want a box of integer. Okay? So that's why we have this notation there. Now this can be a little bit simplified. And that's going to lead into another concept that we are going to define later in the module. This can be a little bit simplified in the sense that you are allowed to say box of integer box equal new box, and then you use those angular bracket, those chevron, without anything in there. Okay? And we are going to see that it's important that you still put them even though they are empty. And then automagically, Java is going to determine that, well, since your variable on the left is meant to hold a reference to a box of integer object, then when you create that object on the right part of the statement, you want to create a box of integer. So Java is going to fill in the blank for you. Java has been able to do that since version 7. It's always approximate. I'm not a good historian, okay? But since version 7, there has been this thing called type inference that has been used with generics to try to actually improve the ability of the Java compiler to actually understand what you mean. So that empty set of angular bracket has a name. It's called a diamond operator, okay? So it's not the same as, again, omitting completely the information. You put the diamond operator as a way to acknowledge, yes, I know I'm using a generic data type and I want to create an object of that generic data type, and that object ought to have the right generic data type. That's what you're saying. But I'm lazy, I'm tired of typing again and again and again box of integer, so you should be able, you meaning the Java compiler, you should be able to figure it out. And that's exactly what Java is going to do with type inference. So what is type inference? Excellent question, but I'm not going to answer it right now. Okay, I need to cover a little bit more stuff. And then we're going to talk about type inference and type erasure, which are the two concepts I'm going to keep teasing you with. But trust me, finally we're going to cover them eventually. So this example begs one question. What if I want to not use the diamond operator, and that would be a good reflex, okay? The logic is, well, okay, Java is capable to figure it out, so why do I have to put empty, an empty operator, okay, empty angular braces? If it's capable to figure it out, it should be capable to figure it out, that I need the braces there. Okay, yes, that's true, but no, it doesn't work. If you do not use the diamond operator, what you are doing, actually, you are reverting back to something called raw data types. So what are raw data types? So let's take a look at this code here. Okay, we have our good old public class box of T. Okay, and then we create what we call a raw box. So the variable raw box is meant to hold a reference to an object of class box. Notice that when I declare the raw box reference variable here, I didn't say a box of something. I didn't use the generics notation. Okay, first difference. And then second difference, when I use a constructor, I didn't use the diamond operator. I didn't use, the syntax to specify actually the data type parameter at all. So you can see at the bottom half on the bottom half of the slide what it would look like if I was actually trying to specify, box of integer here. But I'm not even doing that. I'm not even using the diamond operator. So when you do this, when you are actually creating objects like this and assigning them to a box without saying box of something, so in both of those cases, you end up with a raw data type, okay? And it boils down to manipulating references to object. We've seen already a few examples where I was telling you, let's do generic programming without generics. How did I achieve this? Well, I just use the object data type, okay, the class object, because the class object can hold a reference to any possible instance you may have on a JVM, right? So that's kind of a way to go backward. So why is it important? Well, legacy. Okay, compatibility with previous code is one of the things we're going to talk about. Okay, but most importantly, right now, as programmers learning Java in 2017, you should not use that. Okay, do not go back to raw types. It's kind of like taking a step backward. Now, to be totally honest, if you were looking at the code, the bytecode that is generated by the compiler, from your code where you sweated really hard to use those generics data type, and it took you an hour to figure out what the compiler was complaining about, and etc. Well, at the end of the day, when you look at the bytecode, that's exactly what's in the bytecode, raw data types. And that's what we're going to talk about when we define actually in more detail type erasure. Okay? Type erasure means that when the compiler is done processing your source code with all those generics, then the bytecode is backward compatible with a version of Java that didn't have generics. And the way we achieve that is by actually erasing the information about generics, okay? And we end up with raw data types. But you should not write code with raw data types, okay? Remember, generics, the only advantage is they allow the compiler to catch errors on your behalf, right? So yes, you do extra work. You put generic notation, you spend the time. The reward is that the compiler catches some errors for you. And then when the compiler is done making its detection, then we don't need generics anymore. That's the philosophy of Java, okay? And we could argue on that because there are other languages where generic information is available at runtime. And guess what? Oh wonder, those languages, to go back to your question, they are much better at doing metaprogramming on generics. Okay. All right. So the rule is if we have a parameterized type, okay, and we try to assign it to its raw type, that's okay. That's what we did in the previous example. Okay, here's another example of it. I have a box of strings, so I create a new object that is actually a type parameterized object. Okay, my reference variable is also type parameterized. Then if I have a raw version of that, I can assign the parameterized version to the raw version, okay? And again, this is really about backward compatibility, okay? Dealing with legacy code. That's been the main motivation for the Java engineers to do it that way. However, you have to be careful about this is okay. This is what we just saw right now, okay? The opposite is not okay. It doesn't go both ways, okay? It's not allowed to assign a row type to a parameterized type. So, well, why? Anybody has an idea of why this is a bad move?
Because you cannot assign the integer object. Like, it's like more specific of integer.
Yeah. Yeah, so that's the idea. The idea is similar to if you have assigned an integer to object, okay? But in this case, yeah, what you're losing is all benefits of generic programming, okay? You have a row type, like the second example at the bottom half of the slide. You have a row type row box, okay? You try to assign it to a box of integer in box. Well, the fact that you defined int box as a box of integer means that you want to use generics, right? You want the Java compiler to be able to do type checking for you, but you just assign something that is a row type. So row type boils down to, you know, the good old-fashioned workaround of using object references. Guess what? There's nothing the Java compiler can do with that. It's so generic, you know, and a reference on object that forget it. There's no type checking. If anything is going to break, it's going to be at runtime. If any inconsistency is detected, that's going to be at runtime. So that's the first type of warning you are going to get, you know, with generics. The second type of warning is when you try to use a row type object to invoke, just a second, to invoke generic methods. So let's take an example. We have a box of string named string box. We create an object of class box of something. So we use the diamond operator. So all of this is nice. Okay, this is generic proper syntax. No problem. Then we have a row box and we assign our string box. So that already we talked about it. You know, this is not so good of an idea. But then we try to call rowbox.set of 8. So I'm trying to pass a parameter, I'm trying to call a method defined on my box class, but the box class is parameterized. The method says I accept a type of, you know, whatever t. So what I'm doing here is that I'm trying to use a parameterized method through a reference variable that says I'm a reference to a row type. So that's okay. There's nothing that's going to work there because Java doesn't have the information to make sure that whatever is in your row box is going to be even remotely compatible with what you expect of a box of string, for example. Okay? You had a question. Sorry, I made you wait.
Yeah.
What's up?
Why do you have to convert the parameterized type into the row type?
Okay, I didn't catch that. Can you?
Well, like why we convert the parameterized type to the raw type?
Why do we do that?
Yeah.
Well, those slides here are not trying to tell you that this is actually a good idea to convert, you know, a parameterized type to a row type. They tell you actually it's a bad idea.
Yeah, but
So they are just defining, you know, these are the things you should do, these are the things you shouldn't do. So when we talk about the thing you shouldn't do, if you ask me why would I do this, I don't know how to answer that because that's a bad idea. It might the problem might be that it's a bad idea, obviously for you. You see what I'm saying? So you come here and you say, well, I don't see why I would possibly ever do something like that is wrong. And that's fine. That just means that you understand it's wrong, right? But we still go over those because for most people that discover those generic rule for the first time you get assaulted with all of this knowledge, you know, about generics, you might not necessarily think that, well, yes, it makes sense, you know, that I can do this, but not do that. See what I mean? So that's why we go over it. But no, there's no good reason here to do that. That's for sure. So we have two types of warnings that we discussed so far, okay? And when you try to compile, those warnings are going to come up as unchecked conversion. So that's the case where you try to assign a reference to a row data type to actually a variable meant to hold the reference on a parameterized data type. And then unchecked invocation, which is when you try to push through and you try to call a method that is using the type parameter in the definition of the class, but you try to call that method from a reference variable that holds a reference to a row data type. Okay? So, all right, that we should get to the point here where you have like the sentence are starting to kind of like melt together for most of you, at least. Okay, so I keep using raw data type, parameterized type, etc. What you need to do is you need to go back after this lecture. You need to go back to the definition. Okay, because right now I defined those terms, but I'm using them, and you didn't have time necessarily to internalize them. So you are going to see that once you go back and you review the definition of this basic vocabulary, and then you reread the slides, it's going to be a lot easier. Okay? So don't freak out if right now, all those sentences are kind of like running together and you don't know exactly the difference between a parameterized data type and a formal data type parameter, stuff like that. That's okay. That's the first exposure. Okay? But that just means that this is a kind of lecture where you are going to gain enormously by working over it, several times. And not necessarily just 2 times, okay? Maybe 3 times, 4 times. It's personal, preference. But okay. So back to those warnings. What are they trying to tell us? Well, they're trying to tell us that we are bypassing the benefits of generics. That's all. Okay. So the code might work. The code might be actually correct. But the only thing Java is telling you, and more specifically the Java compiler, it's telling you, I don't know. You might know what you're doing, but I cannot double check that. This is above my pay grade, okay? So when you do those kind of things, when you have those kind of unchecked warning, immediately realize you are going backward, you are going back to programming in Java before generics were introduced. So you give up on all the benefits of type checking, that they come with. All right. And also the other thing that you should know when you get those warnings is that you should be careful about your unit test. You should make sure that you are not actually going to get all of those problems surface at runtime. Okay. A few years ago, I took an old piece of code that I wrote, when I was a postdoc or something like that, and I tried to freshen it up. But when I wrote it, we didn't have generics. So the first thing that happened when I compiled my code with the latest version of the Java JDK is that I had an incredible amount of unchecked warning, unchecked this and unchecked that. And I was like, what's this? My code used to work, okay? And it took actually a lot of tidying up and work to translate some code that was pre-generic with no type safety to the point where the Java compiler would accept it, even though the code was working. So this has nothing to do with, the code necessarily crashing. It has to do with Java saying, I cannot help you. All right. So again, I already mentioned that, but don't use raw type as a programmer today. Okay. If you start a new project, try to avoid raw types. Okay, as much as you can. There should be no good reason for you to have to avoid to use raw types. Okay, that's the bottom line. Okay, let's take an example here. So we have a class warning demo as the main method. So always the same type of stuff, okay? We're going to use that box class example to death. So we have a box of integer, appropriately named bi, and then we call a method named createBox, that is a static method of that class warning demo, and that createBox method returns a reference to an object of class box, okay? And then we get that reference by calling new box inside the method. So nothing really difficult here, nothing should go wrong, right? Except that we have, this is an indirect example of raw types. So when you try to compile this, you are going to get this error, okay? You get this warning, unchecked or unsafe operation. And by the way, there is a way to have Java provide you with more information. I'm going to show that in the next slide. So this is what the compiler tells you here. If you want to know more about why you are not good with generics, please ask me, -xlint, and I will tell you exactly what you messed up. But for now, what is interesting in this example is that it's exactly the same problem than before, except that things are a little bit more disguised, okay? They are not as obvious. So we have our parameterized type here. When we say box of integer, it's a parameterized type, but here we have a raw type. So this is exactly what we did before, except it doesn't fit nicely on one single line. It's spread in your code. So every time you have a return value, parameters, etc., you can have that kind of bug creep up on you as well. So the crux is right here, when we say pretty much that we assign our raw type that is returned by createBox to a reference variable that was defined with actually a correct parameterized type. So same problem, just a little bit more disguised, a little bit more sneaky. So let's talk about that comment from the compiler that mentioned xlint. Okay, so you have different options to get an expanded feedback from the Java compiler anytime you have this kind of error. So this is what I mean by expanded feedback. Okay, what is in the black box with green font. So this is a little bit easier to interpret. Like some of them can get really nasty actually to interpret. But this one is actually okay. It's telling you I found a box. So the method returned a box. But I was expecting a box of integer. That's it. So that's relatively clear. Okay. To get that extra information, when you compile with javac, you need to use the option -xlint. If you want actually to suppress those unchecked warnings at the command line without having to use annotation throughout your code, you can do it globally by doing -xlint : -unchecked. So if you do -xlint : unchecked, you get more information. If you do -unchecked, you get that information to go away. Okay? And of course, we already covered annotation, so you know already about the add suppress warnings annotation. When you do add suppress warnings of unchecked, these are all the kind of warnings that you are going to remove. Anything that has to do with misuse of row types and misuse of methods that are being accessed by reference on a row type.
So,
Yep.
suppose while initiating my generic, I write like box
Yeah.
b is equal to new box, and then in the diamond operator I'm specifying the integer, and then the round braces and column.
Okay, so the question is, what if I write box b? So I'm not using the parameter, the data type parameter, but then I say new, so a new angular brackets integer box. Okay, new box angular bracket integer parentheses to create. Actually, that's still incorrect.
That is an error.
Yeah,
Or a
that is incorrect because the diamond operator is not used. Okay, what you are doing is, instead of using the shortcut that is actually accepted by Java, which is a diamond operator, you actually specify the full type parameter. So you specify angular brackets around integer, where you call the constructor, but you have not defined your variable correctly. Your variable, by defining it as box b without any actual type parameter, you are saying this is a row type.
Okay, so it will be a raw type or it will be an exception. I want to ask that.
It will be caught at compilation time.
Okay.
It's the same. It's actually an interesting variant of the same problems that we have been going here about, when we try to assign a parameterized data type to a row type. Okay, so that's the problem that you're recreating here in essence. Okay. All right, and we're going to finish real quick with maybe not a question. No, go ahead. Don't hesitate to ask question. Okay.
So the slide which you with the box, with the previous slide.
Previous slide. So this one. Yeah.
If I just want to solve the problem to get rid of the warning, should my static, my create box be of what could be the solution? Should it be static t create box? I add and I return a new instance of box and quotes. Box
Okay.
I'm asking for it.
Yeah. So the question is, in a nutshell, how do we fix this example on the slide? Okay. And some of the things you suggested, you are right on. For example, in this case, we have our box class is not there. Okay, the definition of the box class is not there. But when we say static box create box, we need to be more specific. If we say box, we're using a row type, which is exactly the problem here. So instead, we need to use a parameterized type. Okay, so we would say, for example, my create box is returning actually a value of data type box of integer. If we do box of integer here, that's better, but it's not over. Okay, it's not over because then when we create a new box, again, so here we have two choices. We can say I'm going to create my new box, and I'm going to use a diamond operator. Okay, and the diamond operator in that case should work because I already said that create box return a box of integer. So I'm giving information to the Java compiler, and the diamond operator should actually allow the Java compiler to figure out what is the return type, because you are in a return statement, okay? So once I know the return type, I look at what you want to create and I fill in the blank. The second option should be to say, I'm not taking a chance, okay? I think very few people know exactly the detail of the type inference algorithm that is used in Java. Obviously, the people that implement it and design it, okay? But among programmers, this is not necessarily like, well-spread knowledge. So if you ever have a doubt, it doesn't hurt to say, well, I'm going to return new box of integer parentheses, okay? So this time, you make sure that the Java compiler will have all of the information from you, as opposed to rely on its ability to infer it, okay? Even though that would be, the diamond operator there would be a nice fit, okay? A nice use case, all right? So if you do that, then bingo, you have something that is consistent. That example is working. The only problem is, and we haven't covered that yet because we have not covered, generic method, really. But the problem is, do you want create box to always return boxes of integer? Because if so, maybe you should have called it, create integer box. So if you wanted create box to return something actually more generic, then that solution that I just gave you is not going to cut it, right? Because create box always return a box of integer, actually. Yeah? Yeah.
So I was wondering, instead of so if I have to write this function, could it be written static box, the angular brackets and t inside them? Considering I'm trying to return an instance of generic type parameterized box object, create box, and then I return new box, empty angular brackets, the parentheses.
Okay, so hold on to that for like a few more slides. Okay, actually probably next time. But the bottom line is, the bottom line of the question is, okay, here's how I would write this very generic create box, okay? The problem with that is that you need actually to have a type parameter for create box. So you were on the right path, when you describe, I would add a type parameter here, etc. But you are going to have to add a type parameter to create box to tell it exactly what data type you need to instantiate, okay? And that would be actually the most generic version of create box, we can ever write, okay? In that case, we would say, okay, create box takes a type parameter, let's say t, okay? And I used the type parameter but we didn't see the syntax yet. That's why I want to, make sure that nobody freaks out, because it's going to be covered next slideshow, next session, not right now. But we would say, okay, create box needs a type parameter t, and I'm going to use the type parameter to say that the return value of create box is a box of t. See what I'm saying there? So it's like I'm using a type parameter for the method, and then my return value is expressed as a parameterized data type, which uses my method type parameter in the middle. The t comes from the method, okay? And then inside the method, I can say, well, okay, now I want to create a new, box of t. So that's kind of like the next level. That's what we are going to cover next session, all right? So it's 42. I'm going to stop the recording because it takes a few minutes to actually upload and then process. And this is part of the reason for which we have had so many problems with recording lately. But I'm here, so I can take your question right after, okay? Just give me 1 second to stop the recording and start the upload.